Okay, so today we will be discussing chapter 2, measures of location and spread. Okay, so the first thing you learn in this chapter is about the types of data. So in statistics, we work with mainly we collect observations or we measure variables. So in statistics, it's all about dealing with variables. So when it comes to the types of data, there are mainly two types of data. So what are they? You can see in this table, they have classified data into two types, qualitative and quantitative. So qualitative data is what? Qualitative data is non-numerical data. So maybe you deal with colors, you take the names. So stuff like that are called qualitative. So they are non-numerical. The other type of data we deal with is quantitative. Quantitative data is numerical data. So in statistics, we actually work entirely with quantitative data. Okay, so they have given here examples for qualitative. Examples include your favorite color or names. Okay, so stuff like that. When it comes to quantitative data, children, again, what we do is you can see they have divided the quantitative, the numerical data into two more subsections. So what are they? If you look at it, you can see there's discrete data and continuous data. So we divide quantitative data into two more sections, discrete data and continuous data. So in discrete data, what they say here is discrete data takes specific values in a given range. Just look at the difference between these two. Discrete data takes specific values in a given range, but continuous data takes any value in a given range. What do you mean by that? How does that make a difference between the two variables? So take specific values in a given range. So for example, they say, let's say, for example, they say include the number of girls in a family. So when you say the number of girls in a family, it can be either zero. There can be no girls, or you can have one, you can have two. Like you can see, you get all integer values, right? So you take specific values. Specific values are all integer values. Okay, so then what's the difference with take any value? In continuous, they say take any value, right? So specific values and any value. So for example, they say this includes a person's weight. So when it comes to a person's weight, you can measure it to decimals, right? So you can say that person's weight is, 50.1 or 50.2 kilograms, right? So you can take it to, you can actually take it to even more decimals. You can make it more accurate, right? So that's why they say takes any value in a given range. So let's say we know that the range that this person weighs somewhere between 50 and 60. So between 50 and 60, it could be any value like that. Does it have to be specifically 51 or 52 or 53? No, it can be any decimal value also within that given range. So that is the difference between the data types, discrete and continuous. Okay, so that's the first thing that you need to know here. Okay, so exercise 2A question number 1. They say state whether each of the following variables is qualitative or quantitative. So whether it describes a quantity, a numerical value, or a qualitative is non-numerical. So height of a building. Height of a building is definitely quantitative, right? You measure the height. Height is a quantity, a numerical value. Color of a jumper, qualitative, right? So it's a color, it's qualitative. Time spent waiting in a queue, quantitative. The time is a numerical quantity. Shoe size, quantitative, right? It's quantitative. Names of students in a school, qualitative. Names of students, names, colors, those are all qualitative. Okay, and then question number 2, they say state which of the following statements are true. The weight of apples is discrete data. So when it comes to weight, does weight take specific values in a given range, or does it can take any value in a given range? Weight is any value in a given range, isn't it? The number of apples on the trees in an orchard is discrete data. So what do you think about the number of apples in the orchard? Yes, it is discrete data. Number of apples should be discrete. It can take only specific values, right? Integer values. Okay, then the amount of time it takes a train to make a journey is continuous data. Basically, time. Time is continuous. Yes, hours, minutes, seconds, milliseconds, you can keep breaking time. Okay, so Simhal collected data on car colors by standing at the end of a road and writing down the car colors. The data she collected is quantitative. She collected car colors, right? She collected data on car colors by standing at the end of the and she writes down the car colors. So if she's writing down the car colors, she's not counting the number of cars, but rather she's writing down the colors. So is it quantitative data she collected? No. So that is qualitative data. So this is wrong. Okay, is that clear? Okay, so in the next part, they say large amounts of discrete data can be written as a frequency table. Okay, so frequency tables, I think you might have seen these kinds of frequency table in your O-level exam as well, right? So as a frequency table or as a group data. For example, the table below shows the number of students with specific shoe sizes. So the shoe size is the X variable, and you can see they have given this the number of students in for each category. So for the shoe size 39, there are 3 students. With shoe size 40, we have 17 students. Can you see? So this is called the frequency table. Okay, so we have basically like grouped the for each shoe size, we have given individually how many students are there for each of these sizes. Then they say data can also be presented as grouped frequency. What do you mean by grouped frequency table? The specific data values are not included in the table. Instead, they are grouped. Okay, so what do you mean by grouped data? So I think you can see here, over here, you can see that when you make these categories in this manner, can you see this is a group frequency table, a group data table. Can you see? Okay, so even the shoe size, we could group this. So we could say shoe sizes from 35 to 40 is one group, right? And then from 41, likewise, you can break the groups. Okay, so then they say data can also be presented as a group frequency table. The specific data values are not included in the table. Instead, they are grouped. You will need to know the groups are commonly known as classes. Okay, the groups are commonly known as classes. And you need to know how to find the class boundaries, how to find the midpoint, and how to find the class width. Okay, so let's see how to do these things now. Okay, so just a quick go through of this example to see how these groups are read. So they say here, the time X seconds taken by a random sample of females to run 400 meters is measured and is shown in 2 different tables. Can you see? There are 2 tables and they have each of these tables. They show the time taken to run by a random sample of females to run 400 meters. Okay. So write down the class boundaries for the first row of each table. Okay. So look at the class boundaries. Now in the first table, so can you see what's the difference between the 2 tables? The first table, the boundaries are from, can you see 55 to 65. The next one, 65 to 70, 70 to 75. You can see the place where the first interval ends, I mean the first place ends, the second row starts with that exact same value. Look at the second table, and do you see a difference in the second table? What's the difference? In the first table, you end with 65, you start with 65. Can you see? In the second table, you end with 65 and you start with 66. So there is a slight difference here, right? Okay, so in this table, now in this case, we don't have an issue. We say it may seem that the classes overlap. You can feel over here the classes are overlapping. In here, it doesn't look like it's overlapping. Okay, however, this is not the case. Now you need to know what this means. 55 to 65 is the shorthand form of writing. Look at this. X is greater than or equal 55 and less than 65. So that is really important. So in S1, when they give you the group table in this manner, you should know that this table reads in this manner. X is greater than or equal 55, less than 60. Likewise, you can, the other groups are also exactly written in that same manner, right? So this is X is greater than or equal, X is greater than or equal 65 and less than 70, right? So that's how the whole table is read. Okay, so in this case, this is how it's read. So now when you write it like this, does it seem now, is there an overlap now? 60 to 65, 55 to 65 here, right? So is there an overlap by the way now? So you can see 65. If you get the time value 65, 65 belongs to which row? Which group? 65 value belongs to the second group, 65 to 70. 65 doesn't belong to the first group. Okay, so in that case, the data values don't overlap. Okay, so 65 is specifically said it belongs to this group. Okay, so in this case, the class boundaries. So in this case, your class boundaries are correctly given 55 and 65, 65, 75. These are the class boundaries. Getting the midpoint, I think, is quite easy. What do you have to do to get the midpoint? The midpoint of each class, you have to add the 2 values and divide by 2. So 55 plus 65, add and divide by 2. Midpoint is 60. Right, that is okay, right? So in this case, class boundaries are quite easy. So you get the exact same values for the class boundaries. So 55 and 65 are the class boundaries. However, in table 2, you can see there is no overlap, but there is a gap. There is a gap. And when it comes to time values, you could get decimal values between 65 and 66. So then when there are gaps, what we need to do is we need to fix this. So how do we fix this gap? We actually take the midpoint. Now you can see here 55 to 65, and here it starts with 66. So between 65 to 66, there is actually a gap. So what we do here to fix this gap is, so we fix this into the correct class boundaries. The way we fix this is by taking the mid value. By taking the mid value of 65 and 66. So what is the mid value of 65 and 66? 65.5, right? 65.5. So we replace these two values with 65.5. What about for 70 and 71? What do we do? Okay. So the middle of 70 and 71 will be, what's the midpoint of 70 and 71? It is 70.5. So here the class boundary is now 65.5. Over here also you start from 65.5 and this value will now be 70.5. Then over here this 71 also becomes 70.5. Then 75 to 76 it's 75.5. Can you see I take the mid value between 75 and 76. So this value now again starts with 75.5 and it goes to 90.5. And what about the 55 here? If you could see these the way that we have gone, the pattern. 55, what's the corrected class boundary? 54.5, right? Because you can see here when it's 66, it's 65.5. 71 is 70.5. 76 is 75.5. So similarly, 55 should be 54.5. So these are the class boundaries. Corrected. Now you can see there is an overlap, but you know the way we read it, right? So we read the equal mark comes to the first value. Okay, so even though there's overlap. So this is how you fix when the data has gaps. When the data has gaps, you must fix it. And then you work with the corrected class boundaries and we work with this table. Okay, so in this case, when you take the class width, okay, so what is the class width? Class width is the difference between the upper boundary and the lower boundary, isn't it? So in this case, what's the class width now? So how do you get the class width? Yeah. Okay. So class width, you subtract, right? So class width for table 1 and table 2. What do you see here? Class width for table 1, we have already the corrected boundaries. Directly the class width for table 1 is how much? 65 minus 55. Just directly subtract the values. How much is the class width for table 1? 10. You can see it's 10 for 10 for all of them. Is it? No, it's different. Okay, it's different. The class widths are different for each one, but you can directly take the class width of each specific interval by subtracting the class boundaries. Over here, what's the class width in the first row? So you have to subtract 65.5 from 54.5. So that's going to be 11. Can you see? So that's how we get the class width and the class boundaries. So we'll actually go for a question and try out these. Okay, so let's go for question number 3. Okay, let's try this. The distribution of the lifetimes of torch batteries are shown in the group frequency table below. Write down the class boundaries for the second group. Okay, so looking at this, do we have the corrected class boundaries or do we need to fix these class boundaries? Look at this. You can see you have here 5.9 and this starts from 6.0. So we need to fix this. How do we fix it? We take the mid value between 5.9 and 6.0. Can I know what's the mid value? Add the two values and divide. 5.9 plus 6.0 and divide. What is the value? 5.95. Do you guys agree with me? 5.95. And this one, 6.9. What's the corrected class boundary? 6.9 and 7.0. So the corrected class boundary is 6.95. How did I get this value? We can, to get the midpoint, simply add the two values and divide by 2. Okay, so it's 6.95. Now they are asking us, write down the class boundaries for the second group. So what's the answer? Class boundaries for the second group. This is the second group. What's the class boundaries for the second group? 5.95 to 6.95. This is the class boundaries for the second group. Work out the midpoint of the fifth group. So go to the fifth group. So first 1, 2, 3, 4, 5. This is the fifth group. So in the fifth group, how do I get the midpoint? Okay, so obviously the midpoint, what do you think about the midpoint? Will it be affected by the class boundaries? Now you know the class boundaries are going to change here, right? Okay, so will it be affected by the class boundaries? What do you think? Both sides, I think you can see you are going a 0 point, in this case, a 0.05 backwards and a 0.05 forward. So you are going both ends to both the sides. So if you are not sure, you can actually fix the class boundaries and divide those two values by 2 to get the midpoint. That would be the ideal way to get it. Or else you can understand that since you are going an equal amount to both the sides, the mid value actually will not change. Anyway, let's just go for the corrected class boundaries. What are the corrected class boundaries for 9.0? 8.95, and this one is 9.95. So mid value is what? What is the midpoint? You have to 8.95. You have to add with 9.95 and divide by 2. 8.95 plus 9.95 divide by 2, answer is 9.45. So that is the midpoint of the fifth group. Is that clear? Okay. Let's try the fourth question. Question number 4, they say the group frequency table below shows the distribution of the weights of 16-week-old kittens. Write down the class boundaries for the third group. Okay, so what do you think about the third group? This is the third group, right? 1.4 to 1.5. So when you look at the third group, is it necessary to go for a boundary correction? No, as you can see, 1.4, you end at 1.4 and you start at 1.4. So so therefore this is correctly, I mean, you can see that there are no gaps. So that's what we require. There should not be gaps. So then what are the class boundaries for the third group? Directly 1.4 and 1.5. So you can say class boundaries are 1.4 and 1.5, or you could write 1.4 to, it's better to write class boundaries are 1.4 and 1.5. And then work out the midpoint of the second group. So what's the midpoint of the second group? Simply the second group class boundaries are 1.3 and 1.4, add and divide by 2 to get the middle. So what's the middle, the mid value? 1.35. Okay.